Welcome dear students. Today's session is on Bayes theorem and you will be understanding Bayes theorem and its applications on myClassroom. When you are learning Bayes theorem, first and foremost, you need to know what is Bayes theorem and also when to apply it. Looking just in the question, how to understand that it is a Bayes theorem question. Once you are clear with these two, it's a very simple concept and a very useful and essential concept. Most of the applications in engineering, technology, data science are all on Bayes theorem. So, without any ado, let's see what is Bayes theorem and when to apply it. When to apply Bayes theorem? Whenever you know the final outcome, whenever you know that a final outcome is given to you, an event has happened and you are doing a post-mortem of it, you are identifying why it would have happened. That is when you use Bayes theorem. For example, a person died. Now you are checking whether he died of COVID or non-COVID or whatever. Now this is a question on Bayes theorem. You know that accident has happened. Now, did it happen over a truck or did it happen over a car or a bike or a pedestrian met with an accident? When you are doing this post-mortem, then it is a question on Bayes theorem. You knew that the stock market fell. Now you are identifying what could be the reason. The question on Bayes theorem. Whenever a final outcome is known to you and you are finding probability of the intermediates, then it is a question on Bayes theorem. Now, let's look at it. Bayes theorem needs some total probability. So, just whenever you know that a event A has to happen or event A has happened, now you will identify what all cases are there through which it would have happened. Let's say these are the n cases, E1, E2, E3, so on up to En. They are all mutually exclusive. That means if one occurs, other will not occur and they are exhaustive. Other than these cases, there is nothing else. They are complete. Let us take an example of a friend traveling from road number 1 to road number 2. One place to another place, point number 1 to point number 2. Now, he can travel from 1 to 2 either from road number 1 or from road number 2 or from road number 3, so on up to road number n. He has n options available with him. Other than these options, there is nothing else. There is no other road connecting from 1 to 2. That means these are exhaustive. So, Bayes theorem, whenever you are applying, you have to have these events which are exhaustive. And also, no person can simultaneously travel on two different roads, right? So, these events are exclusive. If one happens, the other will not happen. Now, friend is traveling from 1 to 2. It could be from any one of the n roads. We don't know which route he is going to choose. Let's say he can choose road number 1 with probability P of E1, road number 2 with probability P of E2, road number 3 with probability P of E3, so on, road number n with probability P of En. Let's say you got a bad news call from him that he met with an accident and before he communicates something, call got disconnected and you are unable to connect to him. Now you have to make a guess whether it would have happened on E1 or E2 or E3 or En. Now this is a classic question on Bayes theorem. How to do that? First, find the probability of occurrence of accident. For occurrence of accident, he should have traveled either by E1 or by E2 or by E3 or by En. Now, what is the probability that he will travel by road number 1? P of E1. And in mathematics is replaced by multiplication sign. And given that he is traveling on road number 1, what is the probability of occurrence of accident? P of A given E1. So, what is the probability of occurrence of what is the probability that he will choose road number 1? And given that he has chosen road number 1, what is the probability of occurrence of accident? Or accident may also happen on road number 2. Now, what is the probability that he will choose road number 2? P of E2. And given that he has chosen road number 2, what is the probability of occurrence of accident? Or E3. P of E3, probability of choosing road number 3 by him. and given that he has chosen road number 3, what is the probability of occurrence of accident? So on, complete the entire thing. Last road, P of En. What is the probability that he will choose road number n? P of En. And given that he has chosen road number n, what is the probability of occurrence of accident? P of A given En. This is by your total probability theorem. We have listed down all the cases. Now what is that I want to see? I want to see whether the accident has occurred on E1 or E2 or the E3. What is the relative probabilities of each one of them? Let's say I want to measure the probability of occurrence on road number I. Road number I. So take the part corresponding to road number I and paste it in the numerator, as simple as that. So what is the probability that accident would have occurred on road number I? First he has to choose road number I, probability of which is P of EI, and given that he has chosen road number I, accident occurring probability is P of A given EI, as simple as that. This is a simple Bayes theorem. So probability of occurrence of an accident, you have to write it in the denominator with all possible cases without leaving any one of them, and corresponding to whichever event you are measuring the probability. Given that the accident has happened, what is the probability that he would have traveled by road number I? That is what you are measuring in this. So corresponding to road number I, paste it in the numerator. Let's say I want to check the probability of his traveling on road number 1. So in place of this, I would have copy pasted this particular part, P of E1 into P of A given E1. So this is simple Bayes theorem. Let us see some applications on Bayes theorem. How to identify whether a question is on Bayes theorem? The final outcome, if it is given to you and you are checking the probability of intermediate, that is when you use Bayes theorem. Let's look at this question. There are 3 bags A, B and C. There are 3 bags A, B and C. A contains 4 red and 3 white balls. Bag B contains 5 red and 2 white balls. Bag C contains 1 red and 6 white balls. Though it is equally likely to choose bag A or bag B, they are equally likely events. So probability of choosing bag A is same as probability of choosing bag B. Bag C is chosen with a probability of 1 by 2. So there are 3 bags. In actual situation, probability of choosing any one of the bags would have been 1 by 3. But for whatever reason, he is preferring to choose bag C. So probability of choosing bag C is 1 by 2. If probability of choosing bag C is 1 by 2, the remaining probability, because A and B are equally likely, divide by 2. So bag A, you can make a choice with 1 by 4 probability. Bag B, you choose with probability 1 by 4. And bag C, you choose with probability 1 by 2. Now what is the question? If a bag is chosen at random and a ball drawn from it is found to be red, you have made a choice A, B, C, I don't know which choice you have made, and you have drawn a ball from it and found to be red. You told me that it is a red ball. Now I have to guess whether it was from bag A or bag B or bag C. So what is the question? Given that the ball is found to be red, final outcome is given, find the probability that the bag chosen is C. Find the probability that the bag chosen is C. So final outcome, that the final ball which you have taken is red. Now whether you have taken from bag A or bag B or bag C, we are measuring the probability that we have taken it from bag C. So this is a question on Bayes theorem. So what you have to write in the denominator? The probability of the final outcome, ball coming out to be red. So what all information is given in the question? 1, the 3 bags, probability of you choosing bag C is half, and the remaining half is divided equally among A and B. So probability of you choosing bag A is 1 by 4, bag B is 1 by 4. And what else is given? Bag A is having 4 red and 3 white balls. Bag B is having 5 red and 2 white balls. Bag C is having 1 red and 6 white balls. Now, what is the probability that the ball picked comes out to be red? That ball can come out from bag A or bag B or bag C. So what is the probability that you choose bag A? 1 by 4. And given that you have chosen bag A, what is the probability that you draw a red ball? There are 4 red balls out of 7 red balls. So probability of you drawing a red ball, given that it is bag A, is 4 by 7. Or the red ball can come out of bag B. What is the probability that you choose bag B? 1 by 4. And given that it is bag B, what is the probability of you choosing a red ball? How many red balls are there? 5. Out of total how many? 7. So probability of you choosing a red ball is 5 out of 7. Or red ball can come from bag C. What is the probability that you choose bag C? 1 by 2. And given that you have chosen bag C, what is the probability of your drawing red ball? Total 1 red ball out of 7 balls, 1 by 7. So this is the probability of your drawing a red ball. But what I want to find the probability that this red ball is from bag C. So what is the element corresponding to bag C? 1 by 2 into 1 by 7. So this I have to put it in the numerator. 1 by 2 into 1 by 7, I have to put it in the numerator. This is the results. So simple cancellation, 7 and 7 is getting cancelled, and this is the answer that given that the final ball is red, the probability that the chosen bag is C. So whenever the final outcome is given and you are finding the probability of intermediate, that is when you use Bayes' theorem. Let's look at next question. A card from a pack of 52 cards is lost. Pack of well shuffled cards will have 52 cards in it, and one card is lost. You don't know what it is. From the remaining cards, remaining how many? 51 cards. 2 cards are selected at random and both of them are found to be hearts. So from a pack of 52 cards, a card is lost. You are left with 51 cards. You don't know which card is lost. Now from these 51 cards, I am taking 2 cards out and I found that both of them are hearts. So final outcome that these 2 cards are hearts is already known to me. Now I have to make a guess, find the probability of the missing card to be heart. Now missing card to be heart, I have to check this probability. So final outcome that both the cards I have drawn are hearts is known to me, and I am finding the probability that the missing card is heart. So what all cards are there? Hearts, spades, diamonds and clubs. There are 4 varieties of cards. Now either the missing card could be heart. What is the probability that the missing card is heart? Normally it is 1 out of 4. All 4 are equally alike. Without knowing the final outcome, it is 1 by 4. And what are the non-heart cards? There are 3 spades, diamonds and clubs. And what is the probability that the missing card is not heart? It is 3 out of 4. So when you are drawing 2 cards and finding them to be red, it can happen in any one of these 2 cases, either when the missing card is heart or when the missing card is non-heart. So when the missing card is heart, how many more cards you are left with? There are total 51 cards now, of which 12 of them are hearts and 39 are non-hearts. It's none. When the missing card is non-heart, you will have 13 hearts and 38 non-hearts. So what is the probability that when you are drawing 2 cards, both of them are hearts? First, it can be the case when the missing card is heart. What is the probability that missing card is heart? 1 by 4. And given that the missing card is heart, what is the probability that both the cards which you have drawn are hearts? There are 12 hearts. You are picking 2 out of them. You can pick 2 hearts in 12C2 ways. But total you could have done that in 51 cards. You are drawing any 2 cards at random. That can be done in 51C2. So given that the missing card is heart, probability of both the cards drawn are hearts is 12C2 by 51C2. Or the second case, what is it? missing card is not a heart. What is the probability that missing card is not a heart? 3 by 4. And given that missing card is not a heart, missing card is not a heart. How many more hearts are left? 13 hearts are left out of total 51. So out of 51, I am picking any two cards. I can do that in 51 C2 ways. And what is the probability that both of them turn out to be hearts? 13 C2 divided by 51 C2. Now this is the total probability that from the pack of these 51 cards, if you are drawing two cards, both the cards are hearts. Now what is the question? You want to find the probability that the missing card is heart. That means corresponding to this one. So this part you will have to put it in the numerator. This will be your denominator, and this part you have to select and put it in the numerator. This will be your final result, that given that both the cards from the 51 pack are found to be hearts, the missing card is heart. So whenever final outcome is given to you and you are finding the probability of intermediate, it is Bayes. If you like the video, like the channel, subscribe to it, and wait for a lot more. All the very best.